Welcome to this session on reducing latency on the web with the Azure CDN. It's going to be about the Azure CDN, of course, and how we can use it to make our applications load faster. And basically, as we will see during the talk, the internet is broken and how we can fix or work around the fact that the internet is broken. Who of you is using Azure right now? Anyone using the CDN? Planning on using the CDN? No. Awesome. Then maybe this will change after the session. So I hope you have heard about Azure and that you know about cloud services, storage, and all of that. I see some nods, so that's a good thing. Let's start with introducing myself. I'm Maarten Balliauw. I flew in from Antwerp, Belgium. I'm a technical evangelist at JetBrains, so I work on evangelizing ReSharper, .memory, all of those products there. I'm also a founder of MyGet. Anyone using MyGet? No, you should. If anyone using NuGet? Yes. Okay, awesome. Then you should be looking at MyGet as well. That's basically my my night job. I'm also one of the founding members of the Azure user group in Belgium. So as you can see from all this, my big passion is Azure and everything web related. So everything that runs in a browser or uses HTTP under the covers. You can find more on my blog or on my Twitter account on all these topics. So I try to post interesting links and articles on these topics. So the agenda for today is let's first dive into why we may want to use a CDN for hosting our application and hosting the stuff that we actually want to provide to our users. Then we'll have a look at the Azure CDN, because that's what the talk is about, and how we can use it using either blob containers as the origin of the data that we want to serve up, or using cloud services or websites as the origin of the data we want to serve up. And we'll also look at how we can serve dynamic content using the CDN. It's sort of a strange concept of using this thing from Microsoft that only serves static stuff to also serve dynamic stuff. But there's a couple of interesting things we can do if our data is not too dynamic, which means if it only changes every couple of minutes, then the CDN may actually be of use for those types of applications as well. So let's start with the first thing. Why would we want to use a CDN? Well, whenever you make a request to a website or web application out there, we are requesting an HTML file, which means we are fetching this giant bulk of sort of XML type of application. And it contains references to CSS files, to images, to JavaScript files, to whatever is in there, Google Analytics, user voice, all these different types of external services and external resources. Now, within that CSS file, there will also be references to other images. And within that JavaScript file, maybe a CSS tag is injected into the page, which then loads the CSS file, which may in turn actually load images as well. So there's a lot of content being loaded whenever we fetch just an HTML file using our browser. Problem with that is that browsers have a finite number of concurrent requests they can do per host and in total, which means the more requests we do, the more probable we will run into these limits the browsers have in downloading all this content from the internet. So developers as we are, there's some workarounds for all that. So for example, for CSS, we use bundling and minification, so that all the CSS files are bundled into one file, all the white space is stripped out, so the file is actually smaller to download and faster to download, and we only have one giant CSS file instead of 10 CSS files. We do spriting, so for example, all those small icons are combined into one image, and then we use CSS to show the right part of that sprite of that entire image. There's also the usage of multiple hosts. If you go to Facebook, for example, you will see, if you do a view source, that a lot of their content is coming from a different domain name. And then some more content is coming from another domain name. The reason for that is that the browser supports a number of requests per host. And by using multiple host names to download the content from, we can actually have multiple connections or more connections in parallel for downloading the resources that we are consuming in our pages, which should download faster and render faster. So if we look at, there's actually a very interesting website called BrowserScope, which lists all the differences on pretty much every aspect between all the different browsers out there. If we look at the number of connections per host that are available, that's not a lot. For example, on Chrome, if you have more than 6 resources that have to be downloaded at the same time, well, they will be queued. And then once the first of those 6 is completed, then the 7th will take place, and then the 8th one, and so forth. The maximum number of connections there is 10, which means even if you are using multiple domain names and so on to serve the content from, the maximum number of concurrent connections will be 10. So you're limited to downloading 10 resources at the same time. Now, I'm not sure if it's a good thing or a bad thing if you want to go beyond that, but still, it's a limit that is there. By the way, an interesting fact is that IE Mobile 9 is pretty interesting because it supports 60 concurrent connections, which I would think that my browser on my desktop would be more powerful and allow more outgoing connections, but apparently IE Mobile 9 is the champion in that. So browsers sort of limit what we can do with our pages. Now, even if you are using bundling, minification, and all that, we may still be queued in downloading. So for example, if you look at the Microsoft website and you open the developer tools in IE, what you will see is that the HTML page is loaded first. Then a number of JavaScripts are apparently being loaded, but it's more than 6 coming from the same domain name. So you see that we are actually being queued. And once those are completed, the images will be downloaded. But the images are not sprites, they are just images. So they're downloaded in parallel, those 6. But you see that we are having different intervals of loading all the content for this page. So browsers sort of are broken, and we may want to find something around this and make sure that it actually works by using multiple domains. And Microsoft is apparently doing that, but I don't think it's enough. For example, the images could come from a different domain than the scripts and so forth, so that they are actually downloaded in parallel. Another thing about the internet is that speed of light and TCP don't really like each other. So speed of light is an interesting thing. If you look at the US, for example, and you have US East to US West, that's about 7,400 kilometers. If you want to travel from East Coast to West Coast using speed of light, that would take you about 25 milliseconds to go there, which is quite fast. I would love to be able to go to Finland in 10 milliseconds instead of 4 or 5 hours on an airplane. But yeah, that's speed of light. Problem with speed of light is that it only exists in a vacuum, which means that we have to have this hollow pipe pull out all the air in order to be able to achieve speed of light. So in reality, we are using fiber optics, plastic or glass, and they sort of limit the speed of light because glass has a refraction index and the light can't travel as fast as in a vacuum. So in reality, that cable from East to West Coast in the US will take about 37 milliseconds to go from one side to the other. Now, there's an issue with that because there's probably not one giant cable going from east to west. It's a number of cables connected by switches, connected by routers, connected by whatever devices are in between there. But that means those devices will need some processing time. They will have to check, can this network connect to this network? That may take 2 milliseconds. So those 37 milliseconds may become 45 milliseconds to travel from east to west because of all that. If you look at TCP, you will see that every packet that is being sent also requires an acknowledgement to the person sending the package, which means that for just getting one TCP packet, we have 2 round trips going east to west. So those 37 milliseconds pretty much double. So that more or less becomes 90 milliseconds using TCP and speed of light and everything that's in between there would be the fastest way of going from east to west there. Now, TCP has this wonderful thing where you can specify the packet size of whatever is going over the wire. Usually, that's 1,500 bytes, but the good thing is that we can increase this to 64 kilobytes. However, the internet is completely broken. There's a lot of old hardware there. There's a lot of sysadmins that do not increase this default and so on. So we cannot actually go beyond that because things may break along the way. So we're limited to small packets in TCP. Problem with small packets is that how TCP works, that will actually slow you down. So if you look at TCP slow start, which is the mechanism that's used to connect from one side between a client and a server, TCP slow start actually enforces sort of this graph where you see that, imagine we want to download 256 kilobytes. That's being split up into those 1,500 byte packets in TCP. Problem is that the server only sends one packet back on the initial request. Then the client sends an acknowledgement to the server, and then the server will go, okay, he received this, I'll send 2 now. He acknowledges, server says, okay, that was acknowledged, I'll send 4 now. And that doubles every time an acknowledgement packet comes in. But the problem with that is that for 256 kilobytes, we need quite some round trips between client and server in terms of TCP packets. And those 256 kilobytes with that 90 millisecond latency will become 900 milliseconds to download, which is still not too bad. But if you have a lot of resources taking this time and you have browsers queuing up requests because you're only using 1 or 2 hosts to download everything from, your pages or your application may be loading slowly because of that. Then there's the cost of web load. So on top of the fact that browsers only support a number of concurrent connections, on top of the fact that TCP/IP sort of sucks and speed of light sort of sucks, there's also the cost of serving web loads or static files from a web server. So imagine you are a sysadmin and you install an IIS server and you do not configure anything on that thing and it's all default and Windows Identity Foundation is being used and NTLM is being used and all that. Problem with that is for that 1 kilobyte PNG file you are downloading from the server is actually doing quite a lot of work. It's parsing headers, it's parsing cookies, it may actually look out for a session. It may be doing authentication. It may be looking at whatever is in the requests, and then it will have to return all that's in the request. So for example, if we're using cookies and Windows Identity Foundation has massive cookies, we are sending the cookie to the server. Server has to read the cookie, check what's in there, give me back the 1 kilobyte PNG file, but also the entire cookie that's in there. So that 1 kilobyte PNG file may actually be a request of 4 or 5 kilobytes going over the wire. And IIS may be spending too much time on whatever is around that thing in the IIS pipeline, or Apache or Nginx or whatever server you are using. There's this cost of serving that type of content. So ideally, you want to be moving that content outside of your server to a different environment that doesn't have this entire overhead of everything that's happening there. So just to illustrate, this is a fiddler request where you can see a lot of cookie data is being sent, and basically just to receive one single stupid file, which is probably even smaller than all the headers being sent. So it's a bit stupid to have all that in there. So we may want to fix that. The internet is broken. Browsers and connections are broken. Speed of light and TCP slow start actually are broken. And web load costs a lot to serve. So if the internet is broken, what do good developers do? You would think find a solution to this. No, the internet is old and we cannot just fix this, so we have to resort to workarounds. And an ideal workaround would be serving content from multiple domains and multiple hosts so that the browsers can use the number of concurrent connections they have available to its fullest extent. Another thing is to overcome the speed of light and TCP slow start problem is moving content closer to the user. If you have those 90 milliseconds going from east to west in the US, if we make that 10 milliseconds by moving the server closer to the user, we're actually increasing our download speed of that 256 kilobyte file quite a lot. We also want to serve off our content from a cookie-less domain so that we do not have this overhead of parsing cookies and returning cookies and so on. And we may actually want to move content off the main web server. Make the server actually do the work of your application, all the dynamic content serving APIs and all that, and then move the static things like images, like JavaScript, like CSS to a different domain. So we have basically the best of all these things that are in there. And one of those workarounds that are available is the Azure CDN. So the Azure CDN does exactly that. It can serve content from storage, cloud services, or websites on a separate host name, which can be something Microsoft comes up with, or your own domain name. There's a lot of locations around the globe, so the content you serve through the CDN will be served from a location closer to your user. So we're solving this speed of light and TCP slow start problem there. So there's quite a number of locations, and I actually think there's a location in Helsinki as well. So if you go to this page, you will find all the locations of the CDN edge nodes that will serve up content. You see there's still a number of gaps around the globe where no CDN endpoints are available. What will happen there, I don't know. For example, if you're in Brazil and network routing says that Mexico or US is closest, you will probably be getting content from the US. If internet routing protocols say that Madrid in Spain is closer, then Brazil will be served content from Madrid. So it really depends. And I do hope that a number of these gaps will be filled by Microsoft as well. So how does this work? Imagine we are hosting our stuff over there in Ireland, and we have a user in the south of France. Anyone go to the south of France on vacations? I like it because it's always warm in summer. Belgium is sort of like Finland, a lot of gray weather, not as cold, not as much as snow. But to be sure of good weather in summer, a lot of Belgians go to the south of France on vacation. Now, the problem with France is that internet connections are not that fast, especially not in the south there, in the mountains and so on. So what will happen is, if my application is there in Ireland, and I download from there, this may take a number of milliseconds to download. So imagine that takes 40 milliseconds to download content from that resource. Again, maybe 10, 20 requests going out there. So that's taking quite a lot of time to download all that. Now imagine we enable the CDN. What will happen is that our internet provider will direct our user to the CDN endpoint, maybe in Spain, maybe in Paris, I don't know, depends a little bit on the network topology. And then the CDN endpoint node will connect to the origin, which is in Ireland, download the content from there, and then serve it to the user. Now, this looks cumbersome because we're actually taking a detour through a CDN endpoint. But the good thing about that is on the next request our user does to the same resource, the CDN will have a cached version of the original content and will not have to go back to Ireland to get the original data from the origin there. So the download speed will be much faster. So the first time a request is being made to the CDN, that user will pay a little bit for the fact that it still has to be populated on the CDN endpoint node. But after that, the data will be available and will be served from the CDN node. Does the fact that my user hits the CDN endpoint in Spain, does that also mean that the CDN node in Helsinki will have the same data available? No. So for every CDN endpoint, they all keep their separate version of the original data that was stored in our origin that we configured. So that means that for every CDN node that's out there, this story will happen. So it's not because the data is already cached in Spain, that will also be cached in Helsinki or Paris or London or Amsterdam. All right, so let's see what Azure can do for us and how this works. Let's go to the portal. And as you can see, I'm still using the old new portal. Anyone's been using Azure for longer than, say, 2 years? No? Okay. So there first the Azure portal was a button, then it became a Silverlight portal, then it became this one, and now there's a new one again. But CDN is still in this previous management portal. So to create a CDN endpoint, what we can do is just simply go create new, I think it's an app service, CDN. Quick create, pick our subscription we want to use, where do we want the CDN endpoint to be built, and pick the origin domain. Now, as you can see, if I pick, let's say this one, the origin domain can be a number of things. We can be serving content from storage accounts. We can be serving content from websites or from cloud services, which means every single service that's inside Windows Azure that allows you to serve up content is supported as a CDN origin. So whether you are using virtual machines are actually cloud services as well. So you can basically serve up content to the CDN from whatever origin you want. So let's say I want to serve it up from this storage account there. Let's create our endpoint, and that's actually quite fast. There it is. And we have some settings available. So first thing you may notice is this endpoint. This is the URL to our newly created CDN endpoint, which means if we want to serve data from the CDN, this is the URL we have to prefix our data with. If we fetch /hello.txt on this domain, it will actually go to our storage account and try fetching hello.txt from there. There's a number of options available as well. We can temporarily disable our endpoint, we can enable or disable HTTPS, and we can enable query string support and manage domains. Not a lot of functionality, but for the CDN, this is probably more than enough. But I do want to warn you about one thing. You can use custom domains. So if you, instead of this ugly blah 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 dot msocnd.net URL that I just showed you, you want to use something more pretty, like I don't know, cdn.namesday.fi, you can do that. However, if you want to combine that with supporting HTTPS on the CDN endpoint, that's a bit tricky, because the SSL certificate that's being used if you are using HTTPS on the CDN is an SSL certificate from Microsoft. That's only valid for this really ugly domain name, which means if you serve from a custom domain name, the SSL cert will actually be invalid for that domain name, and you will get a security warning. So if you want to use SSL, you sort of have to use this ugly URL because there's no way currently to provide your own certificate there. All right, I'm not going to use this one. I'm actually going to delete this one. Reason for that is that it takes about an hour for all the CDN endpoints around the world to know about the fact that this URL should map to this storage account. So I created a couple of CDN accounts previously that we will be using during the demos here. So for example, I have this one, which uses a storage account. So let's first see where this resolves to. If we do a trace route to, I really need Windows 10 to be able to do Control V there. If we do a trace route, we will be seeing that this will go to a location that's close to where we are. This should not be going to North Europe or even Amsterdam. Although maybe if the connection out of this building goes through Amsterdam, we may actually end up in Amsterdam. But this will probably end up somewhere close by. We're external right now, not seeing any host names, which is sort of a pity. But you see only 5 hubs to go to the CDN endpoint, of which 2 are actually internal to probably this building. So only 3 hubs to this CDN endpoint, which is quite interesting, because if I'm serving from North Europe, where the storage account is, that may be 14 hubs, for example, and a lot more latency to go there. So this is actually quite good and quite fast. All right, let's see if we can serve up some content from there. This CDN endpoint is based on a storage account, so what I can do is simply use the Azure Management Studio, for example, connect to my storage account, and create a new blob container. Now, anyone used Azure Storage before? Alan, I know. There's a couple of ACLs that you can specify for storage accounts. By default, storage containers will be private, which means only you, the person who has the key to access them, can access the storage container. You also have blob access, where people can request individual blobs if they know the name of the data that's in there, of the resource that's in there. And you can actually also say my entire container is public, where you will get a directory listing of everything that's in there. So for the CDN to work, we will require any of these 2 public options. So let's say blob, and let's call this one demo. We now have a container available, and we can upload some data in there. So let's say I have a hello world txt file, I have a GIF file. Let's upload them to my storage account. If I copy the blob URL, we will be able to see that serving the directory from the blob will work. So this went directly to the storage account without the CDN. My data is there, it's accessible, which means if I can access it in my browser, the CDN can also access it and cache it for subsequent usages. So let's copy our CDN URL. And instead of using this entire storage account name that we have here, which is sort of ugly as well, we can put an even more ugly URL, which is our CDN endpoint, but now the CDN will fetch this data from the storage account and cache it on the node that we are hitting from this location. Fun thing is, if we do Control F5s or F5s, you will see that actually I'm doing Control F5, which means I'm skipping browser cache, but you don't even see the page being loaded a lot. So this is actually really fast coming from the CDN node. So it's quite easy to work with, actually. All right, so what did we just do? Our first request went directly to storage. Then the second request, where I used the CDN URL, went to the CDN. And the CDN went to storage, copied the data, cached it on the CDN endpoint, and then served it to me. The second request and all the control F5s that I was doing were going directly to the CDN nodes. CDN node already had this GIF file in cache, so it was simply serving up that, and our storage account was simply doing nothing, which is quite awesome and quite fast to do. Now, how would you use this in real life? Because now I had to use a tool to actually upload the contents to the CDN and so forth. Well, the way you would do this in real life is by uploading your static files to a blob storage container, either on your build server, either as part of your development process on a developer PC, using a script, using whatever you want, as long as the contents are on the blob URL. So let's see if we can use this in an actual application. So what I've created here in Visual Studio is a simple default ASP.NET MVC application. If I run this thing, you will see package restore is running, luckily quite fast. And yes. So this will simply serve up my page the way I would expect it to be served up. Pretty simple, default boilerplate ASP.NET MVC template. Now, what I want to do is make use of the CDN to serve up everything that makes this page pretty. So CSS, images, JavaScript, and so on. So what I can do is, instead of directly using content here, let's use our CDN URL. Let's say demo1 static as the directory, and then serve from there. So I'm going to do this with all the different URLs that I'm using in here. I should have done a find and replace probably to be faster. But anyway, if we now refresh, we should be getting a very ugly page because our data is not yet on the CDN, and the CDN has no knowledge of the fact that my data is there. So what I could do now is go to my Storage Explorer, create a new blob container there that has the name demo1 static, and then upload my stuff in there. But let's not do that, and let's automate this. So are you guys all developers? Nod. No nod. Okay. So one of the things you can do is make use of the Azure Storage SDK to connect to a storage account, which I'm doing here. I'm going to skip the account key so the recorders cannot access my storage account. What I can do then is create a container if it does not exist, and then set the permissions to being publicly available so that all the data in there is publicly available to whoever wants to download it. Exactly the same thing as I just did in the Storage Explorer. Then loop through my content and scripts directory on my local directory here. And then for every file I have, upload contents to my blob storage account. So let's do that. And let's say we want to synchronize. Shouldn't take too long. This is actually uploading all the contents to my blob container. So if I refresh now in here, we will see demo1 static.
It's not immediate.
Am I still on the microphone? Yeah. Good. So you see everything is there. My CSS is there. Pretty much what I would expect. And if I now go back to my web page, we will see that the page renders fine. And all the data is actually being served off the CDN, except for the dynamic part, which is running on my machine. So if you look at the source of this page, you will see that it's actually referring to the CDN to download all the contents from. All right, now let's do something funny. Since it's almost Friday, we can do something funny. And let's say in our scripts, in our minified bootstrap version, we want to annoy our colleagues saying, is it Friday already? And alert that to our users. Of course, if we refresh now, that will not yet work. So let's say, dear colleague, synchronize again with the storage account so that the CDN will serve up our new file. And if we refresh then, we see nothing happens. So our joke sort of failed. Why did it fail? The answer is in how the CDN works. So the CDN, by default, caches all the content you have on there for 7 days by default. It depends a little bit on the type of content you are serving, but by default, 7 days more or less. Which means my joke will only be visible next Thursday at around this time. So you have to think about this up front. If you want to be able to sort of expire the content that's inside the CDN, we have to do something like setting the cache control header and making sure that the file is only cached for, say, 1 hour or 1 day instead of the default 7 days. But that still means that our content will only be available whenever that content expires, which may be an hour from now if we would have set this cache control header. So another thing we can do is make use of query strings and versioning. So in the portal, we had this checkbox or this button where we could enable query string, and I've enabled it on this account. By doing that, we can append a value to the URL we are requesting, and what the CDN will do is for every resource that you are requesting with a different query string, it will create a different copy of the data there. So if the query string changes, the CDN will not have a cached version of that file and then fetch that file from the blob origin and then serve up the new version of that file. So let's do that. If you go back to our application, to our layout file, and add, say, v equals 1, we will get a new version of this file. Let's do it only for the bootstrap file for now. Now, of course, this is probably not the best approach because we're hard coding the version number in there. So what we could do is, for example, use the current day if we want to expire every day, or probably even better is simply using a variable like I created here, where I'm simply fetching the assembly version of my deployed application and using that as the version for my content, which means that whenever I upload a new version of my application, whenever I recompile, a new version query string will be added and the entire contents on the CDN will be refreshed, even though the old content will still be there, maybe or maybe not. So let's see if our prank now works. Let's Control F5. And if everything goes well, it's still failing. Do we have the query string in there? I may actually have used the wrong file in there. But anyway, so normally if this demo would have worked, we would have seen the alert popping up and seeing the prank that we pulled with our colleagues. All right. Now, a couple more things with versioning and expiration headers. So imagine we set the expiration header to 200 seconds. Every file that's being cached is valid for 200 seconds. One issue with that is, imagine we have a user that hits the Paris CDN endpoint, fetching a script that we specified is 200 second cache expiration, and at 199 seconds, another user fetches the same data from London. And imagine after the expiration, we upload a new version. The guy in London will still have the old file. So you have to make sure that worst case, your expiration will be almost double if you consider all the CDN endpoints that are available globally. So as I said, next to setting output cache headers, what you can do is simply specify a version query string and use, I don't know, the date of today, the assembly version, use Chuck Norris quotes, whatever you want to use as the version identifier, you can input there, but make sure that whenever you want to expire the content, you just simply use a new version in the query string, and then the CDN will fetch a new version from the origin. It's pretty much like in ASP.NET, if you're using output caching, you have this vary by param setting that you can specify. If you're using that, that's basically how the query string versioning in the CDN also works. All right, any one of you used blob storage before? No? Okay. There's this concept of shared access signatures. So when creating data on the storage account or creating data in the container, we could select between private, blob public, or container public. The problem is, if I set it to public, it's available for anyone to be used. If I set it to private, I will have to share one of the two account keys that I have, and people will be able to do everything, including overwriting data and so forth. So is there a way in between where I can conditionally grant access to a given file for a certain amount of time? Well, yes, that's by using shared access signatures. So what you can do is generate a query string that will be recognized by the storage account, saying, look, storage account, if this user with this signature comes to you and requests this file, and it's between midnight and 1 a.m., then you can serve up this file to the user. If he falls beyond that period of time, do not serve the content. That's an interesting approach on a storage account, because the storage account will re-evaluate that shared access signature for every request that's being done using that shared access signature. However, if we set our container to private and we use shared access signatures on the CDN, that will also work, because the CDN simply forwards the shared access signature to the blob storage account, which will evaluate it. It's valid, so it will serve up the content and it will be available on the CDN. So even on the CDN, we can serve up private files using the shared access signature. Problem with that is, if we have a shared access signature that specifies that the signature is only valid for, say, 10 minutes, and we do not set cache expiry on the file that we are doing, serving up, what will happen? Well, users using that URL where the signature may be invalid in 2 days, the URL will still resolve and still serve up the original file, because the CDN will keep the cache and not forward to blob storage again, and also not re-evaluate the shared access signature. So if you're using this approach and you're using the CDN in combination with that, do set cache control headers, because otherwise your shared access signature may not be a very good idea to use, because the content will be available anyway for the default 7 days. All right, right now we've been manually uploading stuff to our Azure storage accounts. Another approach we can take is serve up content from our cloud service or our website. So that's actually pretty simple. We just create a new CDN endpoint, point it to a cloud service or a website, and then the CDN will serve up files from there. So let's have a look at how that works. What I've created here is another application, which is, again, the default ASP.NET MVC template. And what you will see is that it doesn't resolve anything. Reason for that is the CDN has no access to the files that I'm actually trying to serve up from there. So the scenario we want to have here is that whenever we use, whenever we use the CDN endpoints to download our CSS or our images, we want the CDN to connect to the server where we are hosting the application, serve up the CSS or the images or whatever we are serving up, and then have the CDN cache that for subsequent requests in there. How can we do that? Well, apparently we have to somehow resolve this demo2 static URL. Reason why I've done this is since I wanted to use one CDN endpoint for all my demos, I sort of moved everything into a directory. It's probably also a good approach to be able to use the same CDN endpoint or the same custom domain name for a CDN endpoint for a variety of different types of resources. So somehow I have to make sure that my content is served up under this directory and not under the root of my application. So there's a way of doing that. What we can do in our application is go to our configuration file, our webconfig, and use something like URL rewriting. And what we're doing here is basically capturing every request coming in, and if the URL matches demo2 static, we are sort of rewriting the URL to not include demo2 static, so that the file is actually being served on that URL. So if I would go to my application running on Azure and go to this URL, it would actually work. So let's do that and publish our application. So basically upload the deployment we currently have live. I think this is my password. Yes, I'm okay with that. Either the password is wrong or I do not have an outgoing connection to this specific type of service on Azure. Let's try another password. And if that doesn't work, my entire demo fails. Yes, it worked. So if we now refresh, we should be seeing CSS, images, and so on. So it takes a while, but it now works because the CDN will query this /demo2 static URL, and from there, my server actually serves it to the CDN, which in turn serves it to me. Now, the reason why I wanted to show you this is that this is good for my demo, because I can use different subdirectories for everything. But I wanted to show you this URL rewriting feature because probably you do not want to serve every possible file through the CDN. Imagine you are hosting PDFs and so on that can only be accessed whenever a specific signature is in the URL or something like that. You probably do not want to expose that over the CDN. By enabling the CDN on your server, you're actually doing that. You're exposing whatever is on your server over the CDN. If you do not set a cache expiry header, the PDF that you are serving and trying to protect will be available on the CDN for 7 days if someone uses that URL. So that's an issue. So that's why I wanted to show you this, because you can actually go beyond the simple filter that I did here and say that, for example, I only want to serve up content from the content directory and not whatever other directory or whatever other paths that I have available on my server. So by using these rewrite rules, you can sort of specify what you want to expose over the CDN. All right, there's a couple of other things I want to note here. So by default, my IIS will also serve up the content, and the content may be available for a number of days on the CDN. I told you, do set cache expiry headers. Well, you can do that from your web config as well by simply adding this client cache and setting the max age to, say, 1 hour, for example. This means that the content will only be available for 1 hour. Another thing I wanted to note, and I'm almost out of time, I see, is that you can also do things like compression and so forth. So I started this talk with saying people use bundling, minification, and all those kinds of nifty features. One other feature for speeding up the internet is compressing content. CSS images and so on are actually ideal candidates to apply compression to. And in IIS, what you can do is simply configure compression in your web config file, and this will actually make sure that all these types of content are served with gzip compression to the CDN. And then the CDN serves that gzipped content to my user. So actually, whatever you send to the CDN will be served by the CDN. So if you want to apply compression, feel free to do so, and the CDN will simply serve up compressed files instead of the normal type of file that you are deploying there. I think I may have to skip one single topic, which is serving dynamic content, but I will give you the general idea there. So I don't know what types of applications you are building, but imagine you are building an application that has dynamic content that's not dynamic as in every request returns a different result. Maybe every request within a 5-minute time frame should return the same result, or every request with the same query string should return the same results. So for example, this PDF example I gave you, imagine you are generating an invoice and the invoice ID is in the query string. What you want to do is simply generate it once and from then on serve up the generated invoice without regenerating it every time. That's this type of dynamic content that I'm referring to. By using query strings and so forth, you can actually do this. So imagine you are serving up this PDF file with an expiration of, say, 1 hour or 5 minutes or 10 minutes, and you're serving that through the CDN. What will happen is the first request to your server from the CDN endpoint will actually generate the invoice, send it back to your user, but every next request within that 10-minute expiration time frame will simply be served from the CDN without regenerating the invoice every time again. So there's a couple of interesting things that you can do with generated documents, displaying charts, for example, on applications. I know Peter, who is a colleague of Alan, he told me yesterday that they are building an application where they're actually using the CDN to serve up like 90% or 95% of all their data. They're simply generating the data and then serving it through blob storage because it only changes every 5 or 10 minutes, which is an interesting approach because it's still dynamic. The application will still refresh fetching that data, but we don't have to run big servers to be able to generate that content every time. They're actually running this application, which is used by, I don't know if I can say it, but a lot of users, but they're only using 2 small instances to serve it because they only get 1 request from every CDN endpoint node that's being hit, and from then on the CDN will serve the content. And all they are basically paying for is bandwidth on the CDN nodes. So in conclusion, we have learned that the internet is broken. We have learned that we cannot fix it easily, but we have learned that there's a couple of workarounds available. There's a CDN that we can use, which solves the fact that speed of light is broken and moves the content closer to the user. We've learned that the CDN can be used to serve content from multiple domain names, multiple host names, so we can have more concurrent connections from our browsers to the CDN endpoint. And we've learned that we can serve it from whatever origin we want in Azure, even for dynamic content. And with that, I think we're done for today. Any questions? In that case, I guess it's lunchtime.